Hello everyone, welcome to another exciting video of my YouTube channel Data Science with Sam. So this episode is a continuation of my deep learning series that started a month back. In my previous videos, I talked about neural network, the basic building block of deep learning world. I also spoke about how neural network mimicked human brain with a combination of different neurons in three different layers, such as input layer, hidden layer, and output layer. I also give you a brief explanation of the model hyperparameters that you need to select during your neural network model building phase. So I'll definitely encourage you to go back to those videos, watch it one more time before you proceed further. And also don't forget to smash the like button and subscribe to my channel as more videos related to deep learning, machine learning, and data science are forthcoming. Now, in today's video, I'll talk about a very widely popular neural network. Can you guess it? Well, it's convolutional neural network, which played a pivotal role in the computer vision world because it helps you to identify objects in a far distance. It helps you to classify different objects in a particular static image. Also, it helps you to detect something in a running video. Like Tesla autonomous car, like how they usually detect objects when they're moving on the street. Well, they use kind of like a very complicated CNN architecture. But I'm not going to teach you that now, but I'll definitely tell you a very basic CNN architecture that you can use for your data science work. And then you can keep building on it and you can improvise that for any kind of computer vision work. So let's check out in the next section how you can build a very basic CNN architecture from scratch. So the fundamental concept of convolutional neural network or CNN architecture is based on neural network components that I discussed in one of my previous videos. The convolutional neural network also based on the similar components such as input layer, hidden layer, and output layer to process the image and provide classification results accordingly. In addition to those layers, it also has some layers such as convolutional layer, maximal layer. It will help us to extract the feature, provide the feature map, and pass it on to hidden layer accordingly. Now, let's check out this architecture that gives you a thorough rundown of how convolutional neural network architecture looks like in reality. So as you can see on the left side of the screen, the input image, which is nothing but an RGB image of a cat. So what is RGB? RGB is nothing but it's a red, green, blue image. The most of our images are RGB. And apart from that, sometimes we also deal with grayscale image. So what's the actual matrix representation of the image? Because that's exactly what we deal with in the neuron. So in the actual matrix representation of this input image is 2 to 4 by 2 to 4 by 3. So that means that this image is a resolution of 2 to 4 and it actually has an RGB channel as it corresponds to parameter 3. So once we pass this image to our first convolutional layer, let's see what happens. So in the first convolutional layer, what it does, it processes the image and extract all the features. So we use a talk technique called kernel to extract the feature from the image. So kernel is more of like a filter, and what it does, the filter usually calculates dot product with the matrix representation of the input image, and that helps to extract all the feature and pass it on to the next layer. So while kernel is extracting the feature from an image, there is another technique called padding that determines that the amount of pixel that will be passed on to the next layer. So with the combination of kernel and padding, convolutional layer extract all the features from the image. There is another technique called stride that helps us determine that how many steps the image will move forward. So in most of the cases, the stride value is 1. So the reason we have a default value 1 because usually in a convolutional neural network architecture, the image processes one step at a time. So from one layer to another layer, that's how it processes. Now, after we get done in the first convolutional layer, you could see, you want to see the output dimension. So in CNN architecture, we call it as feature map. So the feature map is nothing but the output dimension of the convolutional layer as it denotes here. And as you can see, there is no change in the actual image resolution because it stays the same, 2 to 4 into 2 to 4. But the channel, that parameter is kind of like flexible, because there is no such, I would say, rule of thumb that that you have to keep the same channel value while you're processing through the convolutional neural network. You can definitely change it. So that's why this channel value is more of like a variable number. So based on the channel value, you can actually calculate the final nodes or neuron counts. So now this is the final kind of like feature map from the first convolutional layer. Now let's move on to the next section. So then the next layer, you will see there is a thing called max pool layer. So the reason we use max pool layer, because the combination of neurons should not overburden our architecture. We have to keep our image resolution or the feature map minimal so that our CNN architecture can process the image in quicker time with the improved accuracy. So in order to do that, sometimes we have to go through a trial and error approach to find out what's the optimal number of max pool layer. So what max pool layer does, it just downsample the image resolution. As you can see in the second layer, we have 4x4 max pool layer. So what it's doing right now, it's downsampling the image, the actual feature map coming out of this convolutional layer to 16 by 16 into channel. It's just a division. Okay, so what it's like, what it does is like dividing 2 to 4 by 4, and then it processes the feature map accordingly. So once you get done with this max pool layer, so you have another kind of improved feature map with a lower image resolution, but it has all the key features intact. Because one of the main aspects of max pool layer is to shrink the image, the feature map, but it will capture the main key features which will be passed in the further layers to calculate the main computation. Now, once you're done with the first max pool layer, now it's your choice whether you want to include another convolutional layer to improve the accuracy or build a more robust architecture. But here I'm just giving a simple overview of that architecture. So I did not include any other convolutional layer, but you can definitely include another convolutional layer architecture to make your architecture maybe more robust, but it will become more complicated. So, so as I said before, there is no rule of thumb here. You just kind of like have to perform trial and error approach. You are entitled to add as many as convolutional and max pool layer to your architecture as long as it gives you a better accuracy. So in this neural network, in a simple one, I introduce another max pool layer to downgrade the sample feature map to 8 by 8 and channel. So once I downgrade it to this to feature map, so now what I'm going to do, that this particular feature map will be flattened and pass it on to the linear network. Because before that, we are only talking about the convolutional layer where we kind of follow the non-linearity concept. But when we pass the non-linearity concept feature map to an activation function, we have to make sure that the feature map is flattened before you pass to the actual linear layer. So what a linear layer is doing here is basically getting all the feature map value from the convolutional layers or from the last layers, whether it's max pool or convolutional, and pass it on to this hidden layer. So in the hidden layer section, we sometimes we perform activation function before the hidden layer, or in between the hidden layer, or sometimes we do it after the hidden layer. So in general cases, the best practice is to use 2 linear layers. Okay, so you actually get the data, get the feature map from convolutional layer, pass it on to first neural network, linear layer, and once the first linear layer will complete the calculation, then it will proceed to the next one. But here I'm just showing you just one linear layer, and that linear layer will also coincide with the ReLU activation and a dropout layer function. So now what this ReLU activation does. So obviously ReLU activation will determine that how activation will be performed, how the actual feature map will be translated into the main output layer. So once we perform the ReLU activation, then we also introduce this to dropout layer because in some cases we've seen some data overfitting issues in the CNN architecture. So to avoid the data overfitting, we introduce another layer called dropout layer before we publish the final feature map or the results to output layer. So in the output layer, as you can see, there's two circles on the right side. The reason I mentioned two circles here because in this CNN architecture, it classifies two things. Okay, it classifies whether an image is a cat or dog. So that means we're dealing with two classes. So based on our final class values, the final feature map will shape like that. So final feature map is nothing but the total number of nodes, means it's a combination of all the final feature map and multiplied by the number of classes. So in some cases, what happens that your final class will be either 2 or 3 or how many predict outcomes you want. Okay, like in this case, you are just we're just dealing with like two classes, whether an image is cat or dog. It's like more of like a binary classification. So that's why the final feature map will hold only value 2 for the number of classes representation. So that's it in a nutshell. So that's kind of like a basic CNN architecture, that how the image actually process through convolutional layer, and then it goes to a series of maxpool layer to downgrade the actual feature map. Then after that, the flattened feature map pass it on to the fully connected linear layers. It also perform the ReLU activation function inside the linear layer before publish the final results in as a form of like two classes. So that's the actual representation of our main CNN architecture. Now let's move on to the next section to conclude this video. So today's video gives you an idea of how you can build a convolutional neural network from the scratch. So we need to use the term CNN most repeatedly because that's kind of like a most popular term. Not the CNN news channel, but CNN means I'm talking about the deep learning CNN. So now you need to understand that how you can code a CNN network, because what I just gave you is just more of like a hypothetical overview of the architecture, but you need to understand how we can actually code it, right? So let me tell you that I have a session coming up that will give you an overview of how you can build a CNN architecture using PyTorch and TensorFlow, one of the most two popular machine learning libraries that have been used to develop CNN architecture in recent days. In computer vision world, people use both these libraries, and I don't have any preference, but obviously I have knowledge in working in both those libraries. So I'll definitely share my experience with you. So let's wait for my next video where I can share you how to develop a CNN architecture using PyTorch or TensorFlow. It will also give an idea about what's the pros and cons of these two libraries. So let's watch out for that video. It's coming soon. And don't forget to like and subscribe to my channel. Otherwise, you will miss out all these exciting videos on deep learning and neural network. So till then, goodbye.